This is MECH1395 hydraulic lab activity number 2. We don't really have a hydraulic full-on industrial fluid power system here. There's no cylinder. All we're really doing is taking pump flow and sending it through a flow meter and through an adjustable needle valve, an adjustable restriction, right now 100% open, and back to tank. And you can see pressure P1 near the pump inlet is not very high. Downstream at P2 a little bit lower because there's some resistance to flow from here to here, not much but a little bit, so this pressure is lower. And near the end, pretty close to the tank, P3 is very close to zero when the flow just goes through the filter and back to tank. As we so the pump is putting out 1 GPM going through the flow meter. It has nowhere else to go except through its own relief valve, which is fully open at 1000 psi, and it starts to crack open just a little bit around 900 psi. Here's the thing: as you start to close this needle valve, right, as I adjust this control on the simulation, that's the simulation version of turning the black knob on the needle valve, and as I close it, watch what happens to P1 and P2 and F1. So I'm closing it, and the flow is not going down. The pressure is starting to go up. Almost 200 psi, 300 psi, 400 psi, 450 psi. So there's all this back pressure because it's hard to push the flow through here. But the pump does. It does push it through there. It has nowhere else for it to go. This motor is running, the pump is turning, and every time it turns, it puts out a little fixed volume of fluid. It's a positive displacement, fixed displacement pump. So all the flow goes through here. Now, if I were to close this completely, that would be infinite resistance to flow, and the pressure would head off towards infinity on P1. But on the way to infinity, it would get to the 900 psi that starts to crack open this valve and provide a new flow path back to tank. So I'll do that. Let's see if I can get this. And look what we have here at about 5% open. The needle valve mostly closed. I've got about 930 psi. Some of the flow, 0.65 GPM, is going through the flow meter and through the relief or the needle valve and back to tank, but some of it is forcing its way through this relief valve. If I back this off again, the pressure drops. The valve completely closes and all the flow essentially goes through the needle valve. If I close it completely, there is no flow path here. This is all static, zero flow here, about 1000 psi on P1, because all the pump flow is forcing its way through this relief valve and back to tank. Remember, pressure in the system is caused by resistance to flow. As the resistance to flow increases, the system pressure upstream of that resistance, it also increases. Once it gets too high, it only increases up to a certain point, and that certain point is limited by the relief valve in the system. It doesn't open all at once. Remember, this valve is like a spring-loaded door that's held closed, and it takes 900 psi of pushing on the door to just barely crack it a little bit and allow a bit of flow through. As you're opening that door, you're actually compressing a real steel coil spring. It has to move some little distance, and as that spring compresses, you need higher and higher force or pressure to push it all the way open. So this door starts to open at 900 and it's fully open at 1000, and all the pump flow goes through it at that point.